guys, Mr. Shaw here. It is great to have you all back, and I'm super excited to dive into the content for this unit. Quarter 3 is going to be focused on geology. Geo meaning rocks, logi meaning study. In quarter 1, we focused on biology, so bio is referring to the study of living things. We looked at cells, genetics, diseases that affect our body. In quarter 2, we looked at environmental science. We focused on the climate and how pollution can potentially damage the climate, how fossil fuels are burned and create air pollution and carbon dioxide, and then how renewable energy can help combat climate change. This unit, we're going to be really driving into rocks, the earth, and some of the disasters that can be caused by interactions there. Earthquakes, volcanoes, things like that. We'll also look at larger scale things like continental drift, dinosaurs, fossils, and everything else that is held as evidence inside the layers of rock beneath us. But this week, we're really going to focus on the smallest level at this, which are minerals. Minerals are the building blocks of all of the rocks that we find, all of the terrain we find. We use minerals in our daily life. Aluminum is a mineral we use for aluminum foil. We use copper. We use gold, a lot of different metals. We also use minerals like quartz to make glass, including the glass behind me. Quartz is also found in mirrors. We use minerals like soil mineral additives to help us grow things. We eat minerals like calcium to help us grow, help our bones be strong. So minerals are everywhere. But the minerals themselves, we can only identify through a set of properties. So today we're going to look at some properties of minerals. Now, it's really hard to find some minerals all by themselves in nature. Most of the time we find them as part of larger rocks. So as we look at these properties, we're going to be looking at rocks, but we use these properties to identify minerals in their purest form. And as we're looking at these rocks, we might find some minerals inside of them. All minerals basically have 3 things in common. The first thing is that they're always solid when you find them in nature. They're not going to be found as a liquid, not as a gas. They will be found as solid things. We can dig for them, we can mine for them, but we'll always find them in a way where we can kind of hold it and move it. The second thing is that they are inorganic, meaning they're non-living. These aren't fruits, they're not seeds, they're not leaves. They are non-living things that never were living and never will be living. And the third thing you should know about minerals is that minerals are always going to be the same all the way through. Their color, their texture, their structure of their molecules, it'll be the same as you go through it. That's why it's really hard to find these things purely in nature, because things are always combining stuff in nature. One example of a mineral that you can find is clay. Most bricks are made out of it. Bricks are usually actually a combination of a couple of different minerals, but for the most part, they are just this one reddish clay color that you find a lot of the time. And if you were to look at this under a microscope, at any angle and in the inside of this brick, you would see basically the same structure all the way through. It's going to be found in solid form in nature, and of course, it is non-living. Here's a set of rocks we'll be working with today, and we're going to be looking at 5 different properties of these rocks. The first property is going to be color. Color is a fairly straightforward property. What color is the rock? What colors do we see? How are they different from each other? How are they different within the rock? The second one is texture, which is how a rock feels. Is it rough? Is it smooth? Is it glassy? Is it coarse like sand? Those are the things that we can use to describe its texture. The third one is streak, which is what color or residue or powder is left behind when we scratch the rock on something. And we're using these porcelain tiles to use that. The fourth one is hardness. Hardness is how hard is the rock. We actually can measure hardness on a scale 1 to 10. 10, the hardest substance we know, is diamond, and that's a 10 on that hardness scale. And a 1 is like talcum powder, which is sort of like baking soda, baking powder, that level of hardness, where it's very, very soft. Finally, fracture. We'll use this little crowbar to figure out what happens when we try to break a rock apart. Does it break into rectangles? Does it break into crystals? What is the shape of the line that the rock breaks along? Starting off, though, with color, there's a couple of different ways we can sort rocks by color. Look at this pile of rocks. What are some colors that you see in this pile of rocks? What are some ways we could sort this pile of rocks? We could sort them by red or not red. We could sort them red, yellow, blue, red, green, gray. We could also sort them by the number of colors we see on the rock. Here, I've got a rock that's got red and green on it, seems, maybe a greenish gray. And here I've got a rock that is really just red. So I've got 1 color, and now I've got 2 colors. Sometimes the color on the rock can be a little bit misleading. I can look here at this rock that looks like it's green and gray. But if I wet my finger and just kind of rub on that green part, the green comes off on my finger a little bit. So this is actually just moss that's grown on the rock. Sometimes you'll find moss and algae if the rock was picked up in a kind of wet area. This one's similar. I've got this reddish dust mark on it, but I can't tell if the red is part of the rock or not. And I realize it looks just like the rust on these rusty nails right here. So this is actually iron, a mineral that's inside the rock, and some of it was exposed to water, or water got into the rock, and it's rusted. So some of these colors aren't actually part of the rock. The moss and the rust are just on the rock. And to really know what the color of the rock is, we have to dig a little bit deeper. Let's take a look at this rock here. First of all, how many colors do you see on this rock? Now, I notice pink, I notice gray, I notice sort of a whitish color. There's a couple different shades of pink. If I move it around in the light, though, another thing that I notice in this rock is that it actually has some tiny crystals in it. You'll kind of see these little glints of light, almost like tiny stars. And there's a lot of rocks that have crystals inside of them. Crystals, of course, can be many different colors. Some of them are clear, some of them are not. Here's another rock that is very similar in color. It doesn't have the gray, but it has some similar pink. And I'm looking again for the same crystals. The shape is a little different, a little more blocky. This is a little bit more smooth. I'm going to pick out all of the rocks that are the same color. This pinkish color, even if they have other colors on them. And see if I can find anything in common with them. So this one, like this one, has a sort of dark gray splotch on it. This rock, like this rock, doesn't have the dark gray, but on the other side, there's still sort of like this sort of peachy gray there. Of the 5 rocks, this is the only one that looks different. These all have crystals in them, but this doesn't. So I think this is probably a different rock from these 4. These 4 rocks are actually a form of granite. Granite is an igneous rock, which we'll learn about on Friday, and has crystals in it from when lava cooled down, and the crystals are what was left behind. Just like ice is made of crystals, rock can have crystals in it too when it's a liquid that freezes. Now, to know more about these rocks, I feel this one is kind of smooth, this one's kind of rough. I move on to texture. Texture is a way of understanding rocks based on how they actually feel. And one good example is this clod that I found. This rock is really rough with a lot of little holes in it. Now, to understand it a little bit better, I'm going to use this wire brush here. The wire brush allows me to scrape away and see if any pieces of it can get smoothed down or if it's rough all the way through. So if I take this rock and rub the wire brush against it, I want to see if I can smooth it down or if it's just going to be rough all the way through, just to make sure that there's nothing on it that's making it that way. But nope, it's rough. This is actually a clod of metal. It got melted down and then cooled because of a fire. So the mineral I mainly see in this is going to be iron, maybe some steel, which is a combination of iron and tin, or iron and nickel. And a lot of times when these metals come together, that's what you end up with. Here's another rock, similar in color, but a much smoother texture. Smooth isn't good enough, though. It's also kind of sandy a little bit. So again, I want to use my wire brush to see, does that come off and get smoother, or does it stay the same? Now this time, you can see the part that I scraped has gotten a little bit lighter. It actually has almost a brownish color, whereas the darker color, the black color, is where I didn't scrape. If I keep scraping, I can see that it leaves behind a lot more lines from the wire brush. This brings us to the rock we saw earlier, this mossy rock. If this is moss, like I think it is, I should be able to scrape it off with my wire brush. And now that I've scraped it, you can see the lines over here of where the moss is scraped off. Now the wire brush is also made of metal. Do you think that that's going to wipe away the iron that's rusted over here, or will it stay? Let's try. Unlike the other rocks, this kind of stays on the rock. It doesn't seem like it's actually scraped away. That tells us something about the texture of the rock, but also about its streak, which is the next phase we'll look at. Streak is what is left behind when we actually scratch the rock against something. And to do this, we need something that's really, really hard. You need something that's harder than the rock so that when you make the scratch, you actually can see what's left behind. These porcelain tiles are great for measuring streak because they're so hard and rocks tend to scratch against it without causing any damage. Let's take our really soft rock from earlier where we were able to scrape away some of the residue. And let's just make a nice mark here and see what's left behind. The streak that comes off of it is brown, even though the rock itself looks black. But that makes sense because when we wiped away the residue with the wire brush, that was brown too. Let's make sure it's not any different if I scrape the black side of the rock instead of the brown side. It still comes off as brown rather than black. A lot of times the color you think a rock is isn't the same as the color of streak the rock leaves behind. And sometimes we find a new color in the rock that we didn't know was there before. Here's a rock that looks kind of purple to me. It's also got white on it. And I want to see what happens if I streak this on the porcelain. But the streak that's left behind is white. And the white isn't just a scratch in the porcelain, it actually is the white that you can see on the splotches of the rock. And it's all left behind on this rock. If I keep streaking this, I keep getting white both on the rock and on the tile. Once you've tested the streak of the rock, the next thing to test is its hardness. You can test a rock's hardness by actually scratching one rock with another rock. If you know one rock is harder, then you can see that the other rock must be softer. For example, I know that this rock and this rock are very different from each other. One of them is made of metal, and one of them is just a sandy-looking rock with some layers. Which one do you think is going to be harder? The rock on the left or the rock on the right? Whichever rock is harder should scratch the rock that's softer. So when I rub them against each other, I should see a mark on the softer rock. So let's go ahead and take this rock and try to scratch the other rock. When I rub it against it, I can see a mark has been left behind, which means this rock is harder. Let's try the reverse. All that happens is that I get scratches on the rock that I was holding in my hand. You can see the scratch right here. And I don't get anything on this one. So the hardest rock is this one. Now that was probably too obvious. So let's try two that are really similar to each other. We found two pink rocks. One of them had crystals in it and one of them didn't. We want to see which one is harder. So first I'll take this rock in my right hand and scratch the one on the left. There are some scratches left behind, although they're not really as strong as the other one. And now let's switch. Oh, this one got scratched pretty bad. That tells me that this rock is actually harder than this rock. Now, another way of testing hardness is actually to take a hammer to the rock and see what happens when it breaks apart. So, here's a rock. All right. We took a piece off of this rock right here. Now, if I keep hammering this rock, it'll keep chipping it in ways that let me know that the metal of my hammer is stronger than the rock. But it doesn't tell me that much about the rock by itself. It just tells me, okay, it can break. To really understand it, I moved to my last stage, which is called fracture. Now, for safety reasons, I've got to use gloves for this part because I'm going to use a hammer and chisel. Turns out one of the most common injuries you can get when you're using tools is actually hammering your finger. I'm not going to make that happen. To fracture something, I want to actually take this chisel and hammer it to see what shape is made when I cut the rock in parts. Now, one thing you'll notice about this rock we're going to use is that it actually has these interesting cuts already in it. They're small little lines. They almost look like they might be fossils. I don't know for sure. And we'll get to fossils a little bit later. This yellow rock is the other one we'll test this on. It's got some streaks in it as well, these little gray lines in the rock. And on the underside, there's this little round spot there. Which rock do you think is going to fracture more easily? Now I'm going to go ahead and take this chisel, set it on the rock, and just start hammering away. That's a little jumping bean here. It's already starting to cut, but not hammering yet. You can already see some cuts that have been made in the rock, but hasn't broken yet. Let's try another one. Really soft rock from earlier. And let's see if Mr. Shaw is strong enough to break this rock into pieces. Ah, right in half. Now, when this rock is broken, it got all crumbly. It's in a lot of little bits. The lines are mostly straight with some jagged parts here and there, And also kind of created a lot of little powdery bits. Some rocks will break really neatly in a blocky type of way. Other rocks will kind of break in little tiny bits like this. One last property of minerals is luster. Luster is how shiny something is. And for the most part, the rocks that I showed you outside are all very dull, partly because it's not very sunny and partly because a lot of them need to be refined. But this is a mineral called a sapphire. Sapphires tend to be pretty high in luster. They have a really clear color as well, but they're pretty shiny. In addition, you've got a carbon-based mineral, diamond, and then a alloy, actually, of silver and gold, making white gold, which is also somewhat lustrous. But if you were to compare them, the diamonds have the highest luster, the sapphire is somewhere in the middle, and the white gold is the lowest of the three in luster. Yes, this is my fiance's engagement ring. These are, in fact, minerals as well. And so you can definitely get a sense of this property as compared to the much duller rocks, less shiny rocks, which have a lower luster.